In finance, and especially in crypto, you have to deal with decimals. Not always you are dealing with whole numbers, whole bitcoins, mostly with it fractions. And there is a particular thing with JavaScript number. Thing is, 0.1 isn't exactly 0.1. Let's see the example. Here we have the very simple test. So we are about to add 0.2 to 0.1, and eventually we are expecting to get 0.3 as a result. So we have variable a, b, c, 0.1, 0.2 and 0.3. Everything should be simple and clear. Now let's run test, and we see that test failing, simply because we are expecting 0.3, which is what we expect, and we have received a bit more than 0.3. Alright, now let's refresh what the number in JavaScript is. Number is represented as a double precision binary floating point format. I'll share the link to the format in the description below. What is important to keep in mind that 0.1 is stored in the binary format. So let's see how does 0.1 looks in the binary representation. Okay, to see how the number is looking in the binary representation, we can print it as a string. To do that, we can do simply console log a dot to string, and while we are saying to string, we will ask it to print in a binary representation. So we will do it for A, for B and for C. Now we can run test. Test is still failing, and now we see console logs of A, B and C. Three console log outputs. As you can see, it's not a very simple representation. It's 000, 111, 000, 111, so everything is not that simple as it looks in a system with base of 10. The thing is that 0.1 is a product of the division of 1 by 10 in the binary system, which in binary is an endless fraction. So, how to solve this problem? The silly solution is that you can convert everything to an integer by multiplying everything by 10 or 100 if it would be two decimal numbers, and then dividing the result by the multiplicator. Let's see. Now we can remove console log statements, and now we can add the new variable, which is going to be a multiplicator. And it's gonna be multiplicator, and it's gonna be equal to 10, because we have only the one number after the decimal point. So now it's gonna be A multiplied by multiplicator plus B multiplied by multiplicator, and then we have those two integer numbers divided by multiplicator to get everything back to decimal form. Don't forget to save. Now we run test again, and as you can see, test is passing. While multiplying by 10 works for simple decimals, it fails in crypto. Why? Because the moment you multiply a value already close to number max safe integer, like a large Ethereum balance in way, you hit an integer overflow. You solve the precision problem but create a scale problem. That's why we need a specialized library. Sure, the problem is not new, and the industry standard is decimal.js. I have already installed decimal.js, so now let's change this test to use decimal.js. First of all, we have to require decimals, and then, well, Copilot is helping us. Yeah, we can delete the previously existing test, add all the brackets. So what we have now, we have A, which is decimal decimal.js wrapped 0.1, we have B, which is decimal.js wrapped 0.1, and C. So we have the utility functionality from decimal.js. So we have A plus B, and now we expect it to be equals C. So let's try it out. Yeah, test is working perfectly now, without any kind of multiplications. Now, a few things about decimal.js. First of all, why decimal.js and not BigInt or big.js? First of all, configuration. Decimal.js allows you to set the precision configuration. Just set decimal, set precision equals 20. You might need 20 digits of precision for some calculation and 8 for others. Second important thing is math operations. Unlike native BigInt, decimal.js handles square roots, powers, and logarithms. If I'm calculating an automated marker, a curve, or a complex RSI indicator for my project Colossus, I need more than just addition and subtraction. I need a full math suite that stays precise. Next thing is rounding models. In finance, how you round up, round down, bunkers rounding is a business requirement. Decimal.js gives you 9 rounding models. Native.js gives you only one, which is mass round. Now, decimal.js usage aspects. First of all, you are dealing with decimal constructor. In decimal.js, you are not dealing with numbers anymore. You are dealing with decimal objects, which are wrapping the actual value. Then you have some kind of workarounds with serialization. In output, we are dealing with strings. It's fine to me to have a string representation of the numbers value, as it will be printed as string to user anyway. The slight trick with the serialization. Eventually, data is transferred as a JSON or XML, so we need a way to serialize and unserialize decimals. Now let's change our test to show the serialization and deserialization examples. Let's call it serialize example, and now we're gonna have only one variable, which is gonna be A. We will introduce no new object, which is gonna be let's call it request body, and yep, it's gonna be a simple object with request object, which is gonna be amount of A. So beautifully, we have A and we have request payload, which is going to be amount of A. Somewhere there can be currency or something like that. So let's see how request body going to be serialized. For that, I don't really need test. All I need to do just console log, and there I gonna throw stringified version of the request body. Don't forget to save, and let's see what we're gonna have in the output. So I have amount, which is equals to 0.1, and 0.1 is represented as a string. Now let's see what I'm gonna get if I will try to deserialize the previously serialized request body. So what we can do now, const, we can do serialize it, and here we can console log serialize it, and then we can console log, and from there we can do JSON parse serialize it, and let's see what we're gonna get. Oh, we don't need that yet. Yeah, so what we have serialized representation of our request body, which is holds amount, which is represented with A is decimal, Now I'm sending to console serialized string, and then I want to see what I'm gonna get if I will deserialize previously serialized request object. And I'm getting back the string, but I don't want to get a string, I want to get back the decimal objects. So what we can do to parse previously serialized strings into decimal object, we can define the list of the decimal keys. So let's say list decimal keys, gonna be amount, price, and decimal key is gonna be amount, price, and total, which is fair enough for the financial application. And the JSON parse function expects the second argument, the function which takes key value of the JSON. And yeah, what we can do, we can check if the decimal keys list includes the key. It means we are dealing with a key which is representing the decimal value. In this case, we are just converting the key value to the decimal object. So let's save this function as decimal converter, decimal replacer. Yep, it's gonna be decimal replacer. Then we will use decimal replacer in our JSON parse statement, and then we save deserialized. So now we have deserialized, which is JSON parse serialized decimal replacer. Nice. So we can remove serialized console log, and now we will see in what kind of object we have deserialized our request body, which was previously serialized. So yeah, we have amount, console log, and we have printed 0.1 not in a string representation, which is decimal object now. Another thing is number limit. Maximum what you can get from the number from in JavaScript is 2 in power of 53. With decimal.js you can get as much more. Now let's see how huge number we can get in decimal.js. So let's call it big number example. Now a not going to be decimal anymore, it's going to be 2, and we will make a in power of 256, which is immensible in just for a number. And let's see what we have now in a. It's huge. In the world of high-stakes finance, you don't get partial credit for being close enough. The slightest precision error doesn't just result in a support ticket, it results in financial liability. If you're building anything that touches money, especially in Web3, stop relying on the native floats. Don't invent the wheel, stick to the industry standards like decimal.js. I'm currently documenting the entire architectural journey of building Colossus, including how we are handling real-time data ingestion and precision at scale. If you want a behind-the-scenes look at technical challenges we are solving before our February launch, join the Telegram community. The link to the Colossus terminal channel in the description. If you've ever been burned by floating point bug in production, drop a comment below. I'd love to hear the horror stories. I'm Yuri, thanks for watching. I'll see you in the next episode.